Alright, we have a test review for you guys here. This is your unit circle test review that I gave you in class today. So you might want to pay attention if you didn't quite understand what we went over in class, or for any particular reason. So I'm going to go ahead and fill out this table here. We're going to basically find all the trig ratios for this for these angles that I give you. So I'm going to try to write over here. I haven't tried this before, so we'll see what happens. We're going to try to find all the trig ratios for 5 pi over 6. So let me see if I can draw this. Okay. So basically what I have is an x and y axis again. Oops, it's a y. And then we're going to say 5 pi over 6. So 5 pi over 6 is actually, if I think about what pi is, which is half a circle, okay, that's the same thing as 6 pi over 6. And what I notice is that the 6's will cancel, leaving me with pi. Okay, that's a half circle. Now, I didn't quite get to 6 pi over 6. I'm only at 5 pi over 6 over here. So I'm going to go most of the way, but not quite making it to 6. I only went 5 pi over 6. So that's what we call this angle, 5 pi over 6. Okay? Now, I should ask myself, let's go to a different color here, what this angle is. How much further did I have to go to get to 6 pi over 6? What is this angle that I have here? Okay? That angle, of course, is pi over 6, because if I had continued pi over 6 further, I would have gotten to 6 pi over 6. So I have 5 of them, and if I got one more, I would have had 6. So what this creates now is a right triangle. 6 pi over 6, of course, is the same thing as 30 degrees. So I have a 30, 60, 90 triangle here. All right, I'm going to go ahead and label this with some numbers here. If this is 30 degrees, this side is negative root 3. Let's call this side right here is negative root 3 over 2. And this side right here is positive 1/2. All right. The y value, this is basically the coordinate right here of this, which I'm telling you is negative root 3 over 2 and positive 1/2. Okay. So what I'm basically saying is that this x coordinate is x over r, and r, the radius, is 1. So if I say this over 1, that's the cosine of this angle. So what I'm basically saying is that the cosine of theta, or I should say the cosine of 5 pi over 6, really, is in fact this x value, which is negative root 3 over 2. Okay? And the sine of 5 pi over 6 is this y value right here, which is a half. Okay, this is a positive half, all right, not a negative, it's a positive half. Okay, so let's fill out this table here. We're going to go over here, we're going to say this is negative root 3 over 2, and the sine, of course, is a positive 1/2. Okay, the tangent, all right, the tangent is going to be the sine over the cosine. So I'm going to write over here what I mean by tangent, sine over cosine. I'm going to basically say that the tangent of theta, for this case, will be 1/2, this fraction, divided by negative root 3 over 2. When you divide by a fraction, you multiply by the reciprocal of the bottom fraction. So what I'm going to say is multiply instead by 2 over negative root 3. So we're going to ignore this now. Multiply straight across. 1 times 2 is 2, and 2 times negative root 3 is negative 2 root 3. Now this would be okay, except I can't leave a radical in my answer. Conventionally, we never do that. So what I'm going to say is multiply the top and bottom of this fraction by root 3. This will help me get rid of this root 3 here. So 2 times root 3 straight across is 2 root 3. And root 3 times itself, remember, is like squaring root 3. It's like saying root 3 squared. Well, the square is going to cancel the square root, so this is basically going to equal 3. So this times this is 3. And don't forget you're multiplying by negative 2. Okay? But these 2's are going to cancel. So what I have left is negative root 3 over 3. And that's actually going to be the tangent of this particular angle, is negative root 3 over 3. Okay? So I want you to keep that in mind, because that's where these things are coming from. Now, as you practice this, you can do this calculation really in your head. Okay? You'll get used to what the reciprocals of what are, and you kind of start to memorize them after you do, I don't know, do this about 40, 50 times. So let's take a look at the secant. The secant, of course, is the reciprocal of cosine. So if I take this cosine answer and flip it upside down, I'll get secant. All right, so secant theta is basically 1 over the cosine of theta. So if the cosine of theta is negative root 3 over 2, in this case it is, that means that the secant of theta is the same thing flipped upside down. So it's negative 2 over root 3. Again, we can't leave a radical on the bottom, so we'll multiply top and bottom by root 3 and multiply straight across. So I say negative 2 times root 3 is negative 2 root 3, and root 3 times itself, of course, is 3. So this will be the secant, in other words, the secant of this answer. So this is going to be negative 2 root 3 over 3. Okay, the cosecant. The cosecant is the reciprocal of sine. So if you take sine's answer and flip it, you'll get cosecant. So if we get the reciprocal of 1 over 2, it's 2 over 1, so it's just 2. Okay, cotangent, we'll take the answer for tangent, and we could flip that. What I'm going to go ahead and observe here, though, is tangent we already have is negative root 3 over 3. So if I go for the cotangent, it's going to be 3 over negative root 3, which means I have to multiply again by root 3 top and bottom. And 3 times root 3 is 3 root 3. And negative root 3 times root 3 is negative 3. Again, these 3's will cancel, so this answer is negative root 3, and that's the cosine answer, negative root 3. Okay, and last but not least, we have the sine of theta plus 90. So I'm going to go ahead and erase some of this stuff here if I can. Let's see what I can do. Big circle here. Erase all this, and we're going to do the sine part. So let's do red, I guess. All right, so we know my angle is 5 pi over 6. And I want what is the sine of theta plus 90. Okay, 90 degrees. In other words, I'm telling you that theta, of course, is 5 pi over 6. 90 degrees, of course, is the same thing as pi over 2 in radians. So what I really want is theta plus 90, which is the sine of 5 pi over 6 plus pi over 2. Now, if you're keen on adding fractions, there's nothing wrong with doing that. You can do that if you want. Okay, if I were to do that and keep it all in radians, this would equal, to add two fractions, we need a common denominator, which means we're going to have to multiply this particular fraction right here by 3, top and bottom. Okay, this is going to give me 5 pi over 6 plus 3 pi over 6, because 2 times 3 is 6. Now I have a common denominator, so I can say 5 plus 3 is a total of 8 pi over 6, which will reduce to 4 pi over 3. Okay, so I want the sine of 4 pi over 3, in other words, is what I'm saying. 4 pi over 3, I know that 3 pi over 3 is the same thing as pi, which is right here. So 4 pi over 3 is pi over 3 further. Of course, pi over 3 is 60 degrees. So if I go pi over 3 further, this angle right here, this whole thing is 4 pi over 3. Okay, now keep in mind, this angle 5 pi over 6 that I started with is actually right here. 5 pi over 6 is right here. And I'm telling you, this angle that I've added to it is in fact what? 90-degree angle. That's what I'm doing. So this was my first angle, this is my second angle, and this is the 90 degrees I'm adding. But what I see here is that because I've added pi over 3 to get past this 180 degrees by pi over 3, that's the same thing as 60 degrees. So I'm telling you this angle right here is 60 degrees, and it creates a right triangle. Now if you know your right triangle, you know that this side is in fact negative 1/2, and this side is negative root 3 over 2. This is the sine of this particular angle, which is negative root 3 over 2. And that's why this answer here is negative root 3 over 2. Okay? And that's pretty much how we do all these problems. If you didn't want to do this fraction thing, we could say 5 pi over 6, okay, is actually, based on my triangle again, 5 pi over 6 is here again, this is pi over 6. This is 5 pi over 6. Pi over 6 is this reference angle right here. So in this triangle, this pi over 6 is 30 degrees. That means that this angle here, 5 pi over 6, was 180 minus what? Minus this 30 that I have right here, which gives me this, which is 150. So this is 150. I could have simply added 90 to 150, and that would have given me 240 degrees, which would have put me back right all the way over here. That's 240 degrees. So you could have done this instead of adding the fractions. It's really up to you or whatever your preference is. So, but what I'm saying though is that if you were to find the sine of 240 degrees, that would have been negative root 3 over 2, which is the same answer. Okay, so let's keep going through these problems. I'll do all of them because I know that's going to be more useful to you. And let's do that. So let's try blue. Okay, we have 11 pi over 6. All right, that's a negative angle. Negative 11 pi over 6. Now, what I know is that negative 12 pi over 6 is the same thing as negative 2 pi, because 12 divided by 6 is 2. Negative 2 pi would actually give me, in the negative direction, a complete circle. I, of course, don't make it a complete circle. I only get to, not to 12 pi, but 11 pi. That's what the angle is after all right here. So I'm going to say then, I'm going to go this far, but not make it. I'm going to have to stop about right there. This is going to be negative 11 pi over 6. Okay. So how far short was I? What is this angle? Let's change this to color code this a little bit. Let's do green. This angle here, this what is called a reference angle. How big is this angle right here? Well, how far short was I to getting to 12 pi? I was only by 1 pi over 6 short. So if I added pi over 6 to 11 pi over 6, I would have gotten 12 pi over 6. So this angle here is pi over 6, which we know is the same thing as 30 degrees. So now I have a triangle again. So this is a 30 degree angle, this is a 60 degree angle. So this is root 3 over 2 based on your special triangle, and this side is a half. Okay, x and y are positive in the first quadrant, so that's the coordinate of this point right there. Okay, so this is the cosine of your 11 pi, negative 11 pi over 6, and this is the sine of a negative 11 pi over 6. So we go ahead and throw them in here in this table. This is root 3 over 2. Remember, the cosine is your x value and sine is your y value, and sine is a half, so we say this. Now, instead of doing all these manipulations like I showed you in the first problem, I'm just going to go straight for the answer for the sake of brevity. Okay, I don't want this to take too long. So sine over cosine is the tangent, so we're going to divide this by this. So if you want to work it out by hand, you can, but eventually as you practice this, you can kind of do it in your head. This is going to give me 1 over root 3, which is the same thing as root 3 over 3. Okay, I'm just going to throw in the answers. Secant is the reciprocal of cosine. So I'm going to take this answer cosine and flip it upside down. That'll give me 2 over root 3, which is the same thing as 2 root 3 over 3. Okay? Now, here I have cosecant, which is the reciprocal of sine, so I'm going to flip 1/2, and it's going to give me 2. And you notice these answers on top and bottom here, these two rows, they look very similar. Okay? And they will. A lot of these answers will look very similar. They'll be off by like signs, like you see here, and here as well. So, and sometimes they'll be the same. You just have to be careful what quadrant you're in. Cotangent is a reciprocal of tangent. We're going to flip this, and this is going to give me positive root 3. And then the sine of this. This angle right here, okay, is negative 11 pi over 6. If I add 90 degrees to it, since this is a negative angle, adding a 90 degrees is actually going to send it backwards. Okay, it's going to send it back counterclockwise. So I'm going to add 90 degrees right here, and I want to figure out now what is this angle. Okay, so if I add 90 degrees to that, here's your 90 degrees here. This new angle is this plus 90. Now keep in mind that negative 11 pi over 6, this is 30 degrees short of a full circle, so this is actually the same thing as negative 330 degrees right here. Okay, this is negative 330 degrees. So if I add 90 to it, okay, it's like basically saying, what is 330 minus 90? That's really what it is by adding it, okay, because this answer will be a negative answer. If you add 100, you'll get negative 230, and then we're just going to add 10 more, so it's going to give me negative 240. Okay, so that's going to be what that is. And negative 240 is way over here, down to this point. This is negative 240 degrees. And what you see here is that if this is negative 180, this half circle, negative 180, how much further did I have to go to get to 240? In other words, what is 240 minus 180? That answer is this reference angle of 60 degrees. That's this now reference angle right here. So what I have now, if I change my color, is another right triangle where this angle is 60. Okay? Because 180 plus 60 is your 240, and that's the negative 240 that you get. So now I know this side is negative 1/2, and this side right here is positive root 3 over 2. And that's going to be this side right here. So this is your sine, okay, and this is your cosine. What they asked me for is sine, so this is root 3 over 2. That's how you find it. Remember, the sine is a y value, because I say it right here, y. Okay? So let's keep going, and then we're going to go a little faster and try to get this done, because I know your attention span is not going to be very good after a couple of these, and you'll get the hang of it anyway. So let's do 2 pi over 3, nice easy one, 2 pi over 3. Okay, pi over 3 you should know is 60 degrees, all right? You really need to know that. Pi over 3 is 60 degrees. So if I say 2 times pi over 3, we're going to say 2 times 60 degrees. Which is the same thing as what? 120 degrees, if you like degrees. So this is basically where pi over 3 would have been. This is 60 degrees right here. Okay, so if I go 2 times pi over 3, this angle here will be 120. That's what I'm telling you when I say all that. What I want, of course, is to find all the trig ratios of that angle. And what I have here is the shortest distance from the x-axis to the terminating side. This is called a reference angle right here. And this reference angle creates a triangle, a right triangle. If this is 120, this reference angle is 60. Okay? So that means I know this side right here and this side right here, based on my special triangle, that this is root 3 over 2, just like the previous problem. And this side right here is negative 1/2 right here. That's what's going on right there. So that's going to go right there. And I say, okay, this is your cosine and this is your sine of this angle, which is the same thing as 2 pi over 3. So the cosine is negative 1/2. The sine is root 3 over 2. The tangent is this divided by this, which we know is negative root 3. Okay, I'm not doing the calculations anymore. You can do that after looking at the first problem. The secant, we're going to flip the cosine upside down. It's going to give me negative 2. The cosecant will flip the sine. So this is going to give me 2 root 3 over 3. The cotangent will flip negative root 3, so that's going to give me negative root 3 over 3. And the sine, we're going to add 90 degrees to this 120 that we have. That's what we're going to say. So we're going to say this angle is 120, we're going to add 90 to it. So what that's going to yield is 210 degrees. 210 degrees is right about here. That's 210 degrees. So if I take this angle and add 90 to it, I should get about a 90 degree angle here. That's what I'm saying, 90 is right here. So this entire angle is 210. That's what I'm telling you. If this angle is 210, and this is 180 for a half circle, this angle right here in between them is a mere 30. And we have another triangle again. This is another 30, 60, 90 triangle. If this is 30, this side will be negative 1/2 right here, based on the special triangle that I know. Okay, and I keep talking about special triangles. I'm going to say this again. This is 30, 60, 90. This is a half. This is root 3 over 2. That's one triangle. The other one is the 45, 45, 90, which means it's an isosceles right triangle. This is 45. This is 45. So this is root 2 over 2. This is root 2 over 2. And the hypotenuse for both is 1. These are your two special triangles as they correspond to the unit circle. So back to this. This is the sine of this angle after I added 90 to it, and the sine is what I want. So this is negative 1/2. That's the answer for that one. Okay, so let's keep moving. Let's see, eraser. All right. Let's see, circle all that. Erase as much as we can. Okay, keep going. Negative root 3, sorry, negative 3 pi over 4 is the next angle. So this is a negative angle, 3 pi over 4. Okay, this is 4 pi over 4 and the negative side here. Remember, this is negative pi. So this is negative pi right here, or 4 pi over 4. I didn't make it to 4 pi over 4, I only made it to 3. So keep in mind, pi over 4, you should remember well, is 45 degrees. So negative pi over 4 is negative 45. That's negative 45 degrees. This is negative 2 pi over 4, which is 90 degrees. This will be negative 3 pi over 4 right here. Okay? This is negative 3 pi over 4. And that is the angle that I'm interested in for this question right here. So, again, the question you're asking yourself is, what is this angle here? That angle, of course, will be pi over 4. Because if I add pi over 4 to 3 pi over 4, I'll get that 4 pi over 4 I wanted, right? And this makes a right triangle. This angle, of course, is referred to as a reference angle in trigonometry. Okay, so we know this is pi over 4, which is 45 degrees. So this triangle is root 2 over 2, negative, and negative root 2 over 2 here. Negative root 2 over here, this side. Okay, this is the sine of this angle right here, and this is the cosine of this angle, and they're the same. So they're both negative root 2 over 2. The tangent is sine over cosine. Divide something by itself, you'll get 1. Secant will flip cosine, so we'll get 2 over negative root 2, which is the same thing as negative root 2. Okay, because we'll get negative 2 root 2 over 2, and the 2's will cancel, is what's going to happen. Cosecant will get the same answer because the sine and cosine are the same. So we'll get the same answer, negative root 2. The cotangent is the reciprocal of tangent. If you flip one upside down, you get 1 again. And now we have to take our 90, add 90 to it thing going on here again. So here's my angle here. If I add 90, remember I'm not going this way, I'm going backwards because I'm adding an angle where this is negative. So if I add to a negative, I'm basically subtracting from that negative quantity. So I'm going backwards 90, which is here, because this is a 45 degree angle, this is a 45 degree angle, this is a 45 degree angle. So this angle total is a right angle. It's 90 is what I'm telling you. So it's going to put me back here on this angle. Now this is a 45 degree angle, I already told you, so this gives me a reference triangle again. And this is positive root 2 over 2, and this is negative root 2 over 2. So this is the angle I want when I add 90, and of course that sine value will be negative root 2 over 2, which is right here. Okay, we're almost done with the table, a couple more to go. So let's see where we end up with that, because I kind of want to get through this and not spend an hour on the video by talking so much. Okay, so negative 225, let's go ahead and do that. Remember, in the negative direction, we're going clockwise. So this is 90, this is 180, negative 180. 225 is going to be here, okay? This is negative 225 degrees. If this is negative 180 right here, and this is negative 225, that means the difference here is 225 minus 180, which is again a 45 degree angle. So this angle right here is 45 degrees. That's what I'm telling you. So I have a special triangle again. Alright, that I know the ratio for. So this will be root 2 over 2, and this will be negative root 2 over 2, and this will be the cosine and the sine of negative 225. So this is negative root 2 over 2. This is positive root 2 over 2. The tangent will be the sine over the cosine, which will give me negative 1. The secant is the reciprocal of cosine, which is going to be, it's going to give me 2 over root 2, which is 2 root 2 over 2, so negative root 2 basically. Cosecant, the reciprocal of sine, if I flip that, it's going to be positive root 2. Cotangent, if I flip negative 1, I get negative 1, and then now we're going to add 90 again. So here I am. I know this angle here is 45 degrees. If I add 90, I'm going again backwards because this angle is negative. So adding to it is going to make it go counterclockwise. So it's going to be here because this will be 45 and this will be 45, and it gives me the right angle that I want, which is 90. So this is where I am here, and this angle, of course, now is 45 degrees. It's the same. Okay, so the 45 degrees is right here. All that's going to happen is that this positive 2 root 2 over 2 is going to become negative 2 root 2 over 2, because this angle here is the same as this angle here. So that's what's going to happen. That's going to be the sine of the new angle when you add 90 to it, so it's going to be negative root 2 over 2. All right. One more angle in this table, 600. Let's go ahead and do it right here, 600 degrees. So 600 degrees is going to go counterclockwise. It's a positive angle. If I go a complete circle, that's 360 degrees. If I keep going, I have to get to 600. Well, what is 600 minus 360? How much further do I have to go? That answer is going to be 240 degrees. So I have to go over another 240. So this is 180, and 240 will end about there. So this entire thing spinned over is called 600 degrees. It makes a complete loop all the way around to here, and then it keeps going to here. Okay, so it's pretty much the same thing as 240 degrees as far as the trig ratios are concerned. But if this is 180 and I had to go over from here to here, which I say is 240, then what is this angle here in between them? Well, 240 minus 180 is what? It's going to be 60. So I have a new triangle, another right triangle here, with a 60-degree angle. Let's change the color on that. Let's make it green, I guess. So I have a triangle here, poorly drawn. Okay, this side is going to be negative root 3 over 2 based on the special triangle, and this side is going to be negative 1/2. This is the cosine and the sine. X is cosine, y is sine for 600. So this is going to be negative 1/2. This is going to be negative root 3 over 2. The tangent will be this divided by this. Okay, this divided by this. So it's going to be a negative divided by negative is a positive, and this is going to be positive root 3. Secant is a reciprocal of cosine, so we flip negative 1/2. This is going to give me negative 2. And then the cosecant, we're going to flip sine, and this is going to give me, looks like negative 2 root 3 over 3. The cotangent will flip the tangent. Okay, it's the same thing as this. The cotangent will be this over this, so it's going to be 1 over root 3. It's going to be positive again, which is the same thing as root 3 over 3. The sine, again, we're going to add 90 to this. If I add 90, I keep going in the counterclockwise direction. So here I am now, and I'm going to add 90, which is going to put me over here somewhere because I'm adding 90 degrees to it. So this is where I am now. This is the new angle that I have right here. Okay, well, this is 240. If I add 90 to 240, I'll get 330. So this angle, this big angle right here, is 330 degrees, which means what's left to get to the full circle is only 30 degrees, because 330 plus 30 is 360. So this gives me a new reference triangle, and then we know this is a new special triangle. This side will be root 3 over 2, and this side will be negative 1/2. This is the sine, this is the cosine. The sine is what I want, so this is negative 1/2. That's literally how you do it. Here's that 90-degree angle that you added. Okay, so I think I can try to jump back to this page if I can exit my full screen, because I don't need the double screen anymore, I don't think. So let me see what I can do here. Okay, let's do the view. And we will go to dual display off. Fantastic. Alright, back to this, and this could put the full screen back on. And then we'll do that. Okay. So let's scroll down. Now we have this. This is what I care about. Alrighty, so we got number 2, the tangent of theta. I want all the trig functions. So the tangent of theta is negative 15 over 8. So we've done all these in class, of course, but let's do it again. Alright, sine is less than 0. So remember that all students take calculus. This tells me that all trig functions are positive here. Sine is positive here, tangent's positive here, cosine's positive here. Sine is less than 0, and remember sine is a y value. And where is y less than 0? In this quadrant and that quadrant, underneath the x-axis here. Tangent is negative, based on what I see here. Tangent is positive here, and it's negative here, so this angle will have to be in the fourth quadrant for this problem. That's all I know about it. I don't know what the angle is, I just know it has to be in the fourth quadrant. So that's your angle right here. This is called theta. Very well. Let's change pen. Let's go here. This gives me a right triangle when I use the reference angle, so I have a right triangle here. Basically what I'm telling you. And the tangent is the y over the x. Okay? And the y here is negative 15. And the x here is 8. Okay? You can figure out the hypotenuse by using the Pythagorean Theorem. We could square this and square this. Okay? 15 squared and 8 squared. If I recall, I believe this should be 17 when you solve it out. Okay, so I think that's what that is. But you can double check on that. I believe that's correct. So I'm going to say then that's what that is. This squared plus this squared is that squared, apparently. So now what I have is I need cosine. I need to find all trig functions that give me the tangent. It's the only one I have. So I need the cosine, I'll need the sine, I will need the secant, I'll need the cosecant, and I'll need the cotangent. Those are all of them that I need. Okay, they give you one, so you need the other 5. The cosine is the x over the r, okay? So it's going to be 8 over 17. The sine is the y over the r, so it's negative 15 over 17. The secant is the reciprocal of cosine, so you take its answer and flip it upside down. So it's 17 over 8. The cosecant is the reciprocal of sine, so it's negative 17 over 15. And the cotangent is the reciprocal of tangent, which is now going to be negative 8 over 15. So your answer is complete. We have all trig functions for number 2. Okay, let's go on to number 3. Just go in order. Alrighty, with my pen. Here we go. We have theta. The cotangent, again, remember, let's go back up here. All students take calculus. Cotangent is the reciprocal of tangent. So wherever tangent is positive, so is cotangent. So it's going to be positive in this quadrant, and it'll be negative here and here. Okay? What they also tell me, though, is that cosine is greater than 0, which means cosine is positive. Cosine is an x value. So cosine is an x value. It's positive in this quadrant and this quadrant. Well, because cosine is positive here, and in fact cotangent is negative here, this is the only quadrant that satisfies this condition and this condition. So I'll be in the fourth quadrant again. Yay for us, right? So we have this theta angle again, which is some random angle I don't really know the magnitude of. Okay, so what I have now is a reference angle of some sort, and then I'll have a right triangle right here. Okay, the cotangent is the x over the y. That's the definition, x over y. Okay, so I'm saying this is x over y. The thing is, though, in this quadrant, x can't be negative because it's a positive in the fourth quadrant. So this is actually 3, and the y is the one that's going to be negative, which is actually negative 1. So x over y, 3 over negative 1, is the same thing as negative what? 3. So this is okay. Now we have to find this missing side, so we'll use the Pythagorean Theorem. 3 squared plus negative 1 squared is equal to this side squared. 3 squared is 9, negative 1 squared is 1, 9 and 1 make 10, so this will be the square root of 10. So now I can go ahead and list all the trig functions. I know cosine, sine, tangent, secant, cosecant. I don't need to find cotangent because they give it to me right here. So I have theta, 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 theta. Cosine is x over the radius, which is 3 over root 10. You can't leave it like that, so multiply top and bottom by root 10. So it's 3 root 10 over 10. Technically is the only answer that's correct. Sine is the opposite. Opposite this reference angle is negative 1 over root 10, which I will rewrite again as negative root 10 over 10. Tangent is the reciprocal of cotangent. So this is basically going to be negative 1/3 if I flip this answer. Secant is the reciprocal of cosine. So if I flip this 3 over root 10, I'll get root 10 over 3. And then cosecant is the reciprocal of sine. If I flip negative 1 over root 10, I'll get negative root 10. That's basically all I get. Okay, so those are your answers for number 3. Let's go to number 4. These are kind of long-winded, but it's good practice for you. Cosecant is 4, cotangent is less than 0. Okay, cosecant is positive wherever sine is positive, because sine is a y value and that's its reciprocal. Cotangent is positive in this quadrant, but it will be negative here. So cotangent is negative, which is what I want it to be because it's less than 0. And because this is in this positive the same place as its reciprocal sine is, it'll be positive here. So this answer is going to be in this quadrant because cotangent is less than 0 here, and cosecant is actually greater than 0 here in this quadrant. Okay, so we're looking at some angle called theta. It's going to be in the second quadrant only. I don't know a whole lot about this, but I'm going to try to pick apart what I do know. I do know that sine is the reciprocal of cosecant, so this is 4 over 1, so sine will be 1 over 4. This tells me right away that this side is 1 of this right triangle and this radius is 4. Okay, what I don't know, this hypotenuse is 4. What I don't know is this, but I can find it by reversing the Pythagorean theorem. 4 squared is 16, 1 squared is 1, so 16 minus 1 is 15. So what this side's actually going to be is negative root 15. Okay, and now from that I can give you all the answers from this. So we're going to say cosine theta is x over r, so it's going to be negative root 15 over 4. Okay, so I have 3 of them. I have cosecant, sine, and cosine. Let's go ahead and do tangent. This will be y over x, we'll say, is negative 1 over root 15, which is the same thing as negative root 15 over 15 when we get rid of the radical on bottom. And then I have 1, 2, 3, 4. I need 2 more. I will need the secant and the cotangent. That's the only 2 I don't know. Secant is the reciprocal of cosine, so we'll flip this upside down. It'll give me negative 4 over root 15, which is the same thing as negative 4 root 15 over 15. Cotangent is the reciprocal of tangent, so we're going to flip this upside down. This is going to give me negative root 15. Okay, let's keep going. That's 2, 3, 4. Now we're on 5. Fantastic. So number 5, we're on this. Tangent is undefined and is some angle between pi and 2 pi. Here's pi, here's 2 pi. So it's going to be some angle between here and here. What it tells me right away, though, is that tangent's undefined, and that pretty much tells me where this answer is going to be. Because I know that tangent is the same thing as y over x. And if this is undefined, that means x had to be 0. And there's only one spot where x is 0 in this interval, and that's right here. And this is where y will be negative 1 on a unit circle. This is a 270-degree angle, in other words, okay? So this is going to be the cosine and the sine for that answer. So the cosine of theta is 0. The sine of theta is negative 1. The tangent of theta would be negative 1 divided by 0, which is undefined, which they told me right here. Let's go and do the others. We're going to find secant, cosecant, and of course cotangent. Secant is the reciprocal of cosine. So if you flip cosine, if you say cosine was 0 over 1 and flip it upside down, you'll get 1 over 0, which is again undefined. Cosecant is reciprocal of sine, which is negative 1, so this will be negative 1 again. And cotangent is, if we say tangent is y over x, cotangent will be x over y. So it's 0 over negative 1, which is 0. So these are all of them for this particular question. Okay, let's keep going. all these answers here. Okay, let's go on to solving these for the angles. Okay. All right, see if we can hash this out. The sine of theta equals 1/2. All right, this is a y value, mind you. Okay, is sine. So what I'm looking at is a positive answer for the y value, and this y is a half. Y is positive in the first and second quadrant, so this is a half as well. And what I have here are two triangles, where the y values for both are a half, because that's a sine, it's a y value. If that's the case, then I know this is root 3 over 2, and this side will be negative root 3 over 2. And I know these special triangles. What the question is specifically asking you for is what is this angle right here, and what is this angle right here? Those are the two answers. There are two answers that satisfy this condition. Well, based on the special triangle that I know, if this side is root 3 over 2, this angle will have to be 30 degrees. So theta will be 30 degrees. And theta will equal this one. This is 30 degrees as well. So 180 minus this 30 degrees will give me this angle that I wanted here, which is actually 150. So this angle is 30 and this angle is 150. And your answers should always be between 0 and 360. Because if you don't, you'll get way too many answers to grade. So just give me the answers between 0 and 360. And that's how you do that question. So let's go ahead and do number 7. I really want to finish this because I too have things to do like you guys do, right? So we have cosine theta equals root 2 over 2. All right, cosine is an x value on your unit circle. And I need an x value that's positive because that's a positive root 2 over 2. Okay, so this is an x value, and this x value right here is positive, and I'm telling you it's root 2 over 2. Well, if that's the x side, the y side is also going to be root 2 over 2 because this is a 45, 45, 90 triangle side. So one of your angles is here, which is in fact 45 degrees. That's one of your answers. The cosine of 45 degrees is root 2 over 2. That is a fact. Okay. But we also have another one. Another triangle that looks like this, where its x side right here is also root 2 over 2, but its y side will be negative root 2 over 2. The one thing I'm interested in is the x side because that's the cosine. So what I have to find also is this angle all the way over here. Okay, but if this is 45 right here, this is also going to be, this one right here is also going to be 45. So basically, what is 360 minus this 45? So it'll tell me this angle that I have right here. So 360 minus 45 is 315. So your other answer is 315 degrees. And that is the answer for number 7. Okay. Moving on to number 8. Okay, cosecant is 2 root 3 over 3. Cosecant is the reciprocal of sine. Sine is positive in the first and second quadrant, so is cosecant. So our answers are going to be in this quadrant and this quadrant. Now, if this is cosecant's value, that means sine's value will be this flipped upside down. So it's going to be 3 over 2 root 3. I don't like that root 3 there, so I'm going to multiply root 3 top and bottom. This will give me 3 times root 3. And when I multiply root 3 times root 3, it gives me 3. So this is going to be 2 times 3, because this times this is actually the same thing as 3. I notice that these cancel. This gives me root 3 over 2. So the sine will be root 3 over 2, and the sine is a y value. So again, I have this. This is root 3 over 2. Same thing here, root 3 over 2. And then I have two triangles again. That means this is a half and this is negative half. And I have to figure out for the question the angles. This angle right here and this angle right here. Well, based on this triangle that I see, if this is a half and this is root 3 over 2, this angle right here must be 60 degrees. So that's one of your answers, 60 degrees. Or we could say this angle here is also 60 degrees, if this is 180 and I subtract this 60 to get this angle, 180 minus 60 is 120. So it's either 60 or 120. Both of these angles will give you a cosecant with this value, in other words. So these are your answers. Okay, go on to number 9. Secant theta equals 2. Secant is the reciprocal of cosine. Where cosine is positive, so is secant. So if I say secant is 2 over 1, cosine will be 1/2. And it's positive. It's an x value. And where's cosine positive? Where is the x positive on your Cartesian coordinate system? Well, it's positive in the first quadrant and the what? And the second quadrant. So we have an angle that looks like this, and we have an angle that looks like this, and this x value, I tell you, is 1/2. If that's the case from the special triangle, I know this y value is √3 over 2. And the other y value is negative √3 over 2. And what I want to find, all these color changes, is this angle here and this angle here. This angle here, if this is 1/2, this angle here again is going to be 60, because you know your triangles, supposedly, right? So if this angle is 60, so is this one right here. So to get this thing, I have to figure out what is 360 minus this 60 that I have right here. 360 minus 60 is 300. So this outside angle is 300 degrees, which is the other answer. So we're just kind of breezing through this. This is pretty simple stuff. Number 10. Sine of theta equals √3 over 2. Very well. Sine is a y value on your unit circle because the radius is 1. So again, sine is positive because it's a y value here in this first quadrant and the second quadrant. So we're going to say, okay, we got this going on here. This is √3 over 2. We got this going on here. This is √3 over 2. And that tells me this side is 1/2 and this side is a -1/2. And the angles I want for the answer is this angle and this angle, because the sine of both of these angles is √3 over 2. This angle, of course, based on this triangle that we see in its sides, is going to be 60 degrees. And this angle here, if this is 60 degrees, this is 60 degrees right here. So 180 minus the 60 right here will tell me this overall angle, and 180 minus 60 is 120. So your answers are 60 or 120 for number 10. And we're going to move on to number 11. So we're going to try to get through this. I know we're all getting tired here. Okay, sine is a y value, and the y value is negative. So the y value will be negative in this quadrant and this quadrant. So this is -1/2. This is -1/2. And I have some sort of triangle here and a triangle here. If that's the case, if this is -1/2, this is going to be √3 over 2, this distance right here. And this is going to be negative √3 over 2, this distance right here. The question, of course, is to find the two angles where this happens, in between 0 and 360. So one of the answers is this angle, and the other answer is all the way around here. Okay, that's where it gets a little confusing sometimes, but bear in mind, if I know this side and this side, if this is -√3 over 2, I can tell you this angle right here is 30 degrees. This is 180, this half circle. So if I add 30 degrees to 180, this will give me this total overall angle, the first one that I want. 180 plus 30 is 210. So that's your first answer. This blue angle is 210. This here is also 30 because this one's 30 over here. It's a same angle here. So if I imagine a full circle as being 360, I can just subtract 30 and that'll give me this angle. So 360 minus 30 is in fact 330. So your two answers are this or this for this question. And keep moving. Number 12. There's light at the end of the tunnel. We're in the last stretch here, guys. All right, so number 12. All right, here we go. Cosine theta equals negative root 2 over 2. This is an x value. And negative root 2 over 2. This is really a terrible drawing. I really can't do much of that. Let's do this again. There we go, a little better. So we're looking at the cosine being negative, so that's an x value that's negative, x value that is negative, so we're going to talk about being over here. And this side is negative root 2 over 2. This will yield two triangles. X is negative in this quadrant, and x will be negative in this quadrant as well. This will be positive root 2 over 2, and this will be negative root 2 over 2. And the question will be asking you for those angles, and the first angle will be this angle right here, and the second angle will be this one all the way over here. If this is root 2 over 2, and this is negative root 2 over 2, this tells me this reference angle that I have right here is 45 degrees. So if this is 45 degrees, and this is 180, what is 180 minus this 45 degrees? That'll tell me this distance. Let's change color so I can explain better. We don't have many colors I haven't used yet, or any. So 180 minus this 45 degrees right here is going to give me this angle right here. Okay? So 180 minus 45 is going to be 135 degrees. So that's one of your answers. This is the angle right here, 135. Okay. Or the answer will be this angle here. That's where I find 180 and I add 45 because this is a 45 degree angle right here. So that's going to give me or 225. So those are your two answers for this question. Number 13, cotangent theta equals negative 1. Cotangent is x over y, okay? So that basically means that x is negative 1 and y is 1. Or at least that ratio will be negative 1. Okay, cotangent is negative, and wherever tangent is negative, and tangent will be negative in this quadrant and this quadrant. So what I basically have is a line here. If I have a 1, positive or negative, it basically means the magnitude or absolute value of this value and this value will be the same. So these x and y quantities, at least their magnitudes, need to be identical. The only triangle that I know where x and y are the same as far as the absolute value of their x and y values is this one, which is the negative root 2 over 2, and the positive root 2 over 2. These numbers are the same because that's a 45, 45, 90 triangle. The sides, the x side and the y side have to be the same. Because if I divide this by this, I'll get what? Negative 1, which is what I wanted. Okay? Because this is going to be the x over the y, and that's what cotangent is. It's x over y. Over here, I'll have positive root 2 over 2 and negative root 2 over 2 here. X divided by y will also give me negative 1. The same thing. So what I'm going to find, of course, is this angle and this angle. That's what I got to find. You always read from the positive x-axis. So if this is a 45 degree angle right here, then 180 minus this 45 will tell me what this angle was. So 180 minus 45 is again going to be 135 degrees. And this angle here is also 45. So what is 360 minus 45 to get this angle? 360 minus 45 will be 315 degrees. Alright, so those are your two answers for that. Let's go ahead and go on to this. Getting there, getting there. Cotangent of negative root 3. Alright, cotangent of negative equals negative root 3. Cotangent theta, alright. Cotangent again is negative in this quadrant and this quadrant. Alright, and remember that this is x over y. So this is really telling, because if I say that's x over y, Okay, I'm telling you that x over y is the same thing as negative root 3 divided by 1. I don't know this to be a side, this x value as a side of one of my special triangles, and I don't know that 1 is a side that I know either from my special triangles for the unit circle. But imagine if I were to divide the top and bottom by 2. Okay, that doesn't really change the answer because I'm doing the same thing at the top and the bottom. So what I see here, though, is that this is something I recognize, and this is something that I recognize as well as being sides of a special triangle. If x is negative root 3 over 2, okay, this is going over here, negative root 3 over 2, and y is positive 1/2, like this, then I have an angle, a triangle here, where this angle right here, this reference angle in other words, will be 30 degrees. But that, of course, is not exactly what I want. What I want actually is what? This angle. So this is 180 minus this 30, so this angle is 150 degrees. That's your first answer. There's another one, of course. Okay, I could take this negative and bring it down here and make this a positive, and that wouldn't change anything. So let's say the y is negative 1/2 and x is positive 3/2. If x is positive 3/2, then I'm over here. This is positive 3/2 and y is negative 1/2. So now I'm in the fourth quadrant, which carries on this thing right here. This angle was 30 degrees, so this angle here is 30 degrees. So now I have 360 minus 30, which will give me this angle, which is 330. And these are your two answers for that question. Number 15. All right, getting there. This is a sine question. Sine is negative. It's a y value, so it's negative here and here. So I have negative root 3 over 2. Here I have negative root 3 over 2. I have pin right here. First thing I want is this angle. And this is negative 1/2, this side right here. So that means this angle that I see right here, this little angle right here, is a 60-degree angle. So if I add that 60 to this 180, it'll give me this whole thing here, okay, which is going to be 240 degrees. The other angle that I seek is the one that's created with this triangle, which looks like this. This angle here is also 60 degrees. So if I say 360 minus 60, this angle right here will be 300. So your two answers are 240 degrees, this one right here, and the other one is 300 degrees. Oops, that's 240 degrees, by the way. Okay, so there you go. Kind of ugly. All right, now let's go ahead and go down to the bottom two, and this will be the end of it. All right. Find the values of the 6 trig functions. Basically, what I'm telling you with these problems is that the terminal side will be on this line somewhere in this quadrant. Okay, the terminal side of your angle. All right, so if I graph this one, I have to figure out 2x minus y equals 0. If 2x minus y equals 0, that means y is equal to 2x. That's a plain Jane line that you've learned from Algebra 1. So the intercept is at the origin, and then the slope says go up to and over 1. So I'm going to say, all right, I will go up to and over 1, or I can go down 2 and back 1, like this. And this gives me basically a line to graph, which is the graph for this equation here. Now, the terminating side will be on this line, and it'll be in the third quadrant, which is right. Let's put it right here. Okay. I know this coordinate is -1, -2. So I know this is a triangle now I can use, and this will be -1, and this side will be -2. I can find this side by using the Pythagorean Theorem. -1 squared is 1, -2 squared is 4, so 1 plus 4 is 5, so this side is the square root of 5, this distance right here. That's the square root of 5. Alrighty. So, now we can find the values of the 6 trig functions. Okay, so I'm going to erase some space, make some space here. Sorry, because I really don't have much. All right, let's go ahead and get them all. So let's do cosine, sine, tangent, secant, cosecant, cotangent. And these will all have theta, I guess, if you want to call it that angle. So we're going to look for this angle theta here. Okay, theta, theta, theta. All right. The cosine is this x value, -1 over the radius, which is √5. So it's -1 over √5. You can't leave the root on the bottom, so this is going to be basically -√5 over 5. The sine will be this value over the hypotenuse, so it's going to be -2 over √5, which is going to give me -2 √5 over 5. The tangent is the y over the x, -2 divided by -1, so this is plane 2. The secant is the reciprocal of cosine. Remember, if cosine is -1 over √5, this will be √5 over -1, which is -√5 all by itself. Okay, cosecant. If sine is -2 over √5, cosecant is √5 over -2. So this is going to be -√5 over 2. And cotangent will be x over y. So it's going to be -1 over -2, which is +1/2. It's a reciprocal of tangent. So that's this one. And we are on to the final one right here. If 4x plus 3y equals 0, that means 3y is equal to -4x. When I divide both sides by 3, this will be y is equal to -4 over 3x. This is an equation I can graph. Okay, so if I were to graph such a thing, all right, I know that the intercept, let's do this in black, I think a different color. I think the intercept here will be at 0, because that's what it is, and we're going to go down 1, 2, 3, 4, and over 1, 2, 3. This will give me a coordinate here that's in the 4th quadrant, which will be where the triangle can be drawn. So this coordinate right here I now know is 3, -4, and I have a right triangle with a terminating side in that quadrant. So what I'm basically looking for is the trig functions for that angle right there. Okay, when I say that. Alrighty, so this is going to be -4, this is going to be 3, and this side, this is a 3, 4, 5 right triangle, Pythagorean triple. So now this is going to be really easy to get the rest of the answers. So let's erase some stuff to get some space again. And we'll get the answers down when we're done. Alright, so this will be cosine, sine, tangent, secant, cosecant, and cotangent. Alrighty, let's get through here. Let's do blue, I guess. Okay. Alright, so cosine is going to be your x over your radius, which is going to be 3 over 5. So your secant will be the reciprocal of that, which is 5 over 3. Your tangent, your sine, will be your opposite over our hypotenuse, so -4 over 5. And the cosecant is the reciprocal of that, which is -5 over 4. Your tangent is your y over your x, so -4 over 3. And your cotangent will be the reciprocal of that, which will be -3 over 4. So these are all of your answers for this one, and we're done with this review. Okay, I hope you enjoyed watching that. Okay, if you liked it, then go ahead and like it. If you loved it, then share it. All right, and yeah, I was told to say that. So I hope you got something out of that, and I hope you learned something. And good luck on your test tomorrow. All right, guys, I appreciate that.